Okay, today's students, our learning objective is congruent triangles, and it's just a continuation of our study of congruent figures. Before we get started on lesson 4.3, 4.4, and 4.5, I wanted to just review 4.1 and 2 real quick. In 4.1 and 4.2, in order for these to be congruent triangles, we had to prove 6 pieces of information. The first piece of information is I had to prove that this angle was congruent to this angle because those were corresponding angles. Here, this angle congruent to this angle, and then this angle over here congruent to this angle. And then, just by doing all that, that's not enough. I had to then go back and prove that this side was congruent to this side, and then this side congruent to this side, and then finally this side congruent to this side. Now once I had all 3 angles of this triangle and all 3 angles of this triangle congruent, and then those 3 sides and those 3 sides, then I knew that those 2 triangles were congruent. And that took quite a bit of time. So now, today's lesson, what we're going to do is we're going to cut that in half. We're going to just use 3 pieces of information. So these are our shortcuts. These are our postulates and theorems that allow us to do this. Alright, so first of all, I'm going to start here with the side, side, side. Side, side, side congruence postulate. What this postulate says is if 3 sides of one triangle are congruent to the 3 corresponding sides, of a second triangle, then the 2 triangles are congruent. So if you look over here, I have 2 triangles that look very similar. And what this is saying is, if I can prove that this side and its corresponding side are congruent, and I can prove that this side and its corresponding side are congruent, and then finally the last side and its corresponding side are congruent, then I can prove that those 2 triangles are congruent. Okay, so here we started with all sides. Now we're going to mix in an angle. Here I've got side, angle, side. So that's 2 sides and 1 angle. So side, angle, side, congruent postulate. What this one says is if 2 sides and the included angle of one triangle are congruent to the corresponding two sides and included angle of a second triangle, then the 2 triangles are congruent. Okay, so here I have 3 sides, but I just want to pick 2 of them. So at random, I'm just going to choose this side here and its corresponding side here. If I can prove that those 2 sides are congruent, and then choose another one, I'm going to choose this one over here. That side congruent to that side. Then I just have that angle left over. And it says the included angle. What that means, if you look over here, it says side, angle, side. The angle has to be between the 2 sides. It has to be included in between them. So here, we're talking about this angle right here and this angle right here. Those are the included angles. And let's go ahead and mark that. That's the included angle. So that means these would be the non-included angles. All right. The next one, notice how these these two had 3 letters, and this one only has 2 letters. And I told you at the beginning that we had 3 pieces of information. Well, this one still has 3 pieces of information, if you think about it. It's called the hypotenuse-leg congruence theorem. And hypotenuse-leg, whenever you have those words involved with a triangle, you have an angle. It's the right angle, because only right angles or right triangles have a hypotenuse and legs. Okay, so first of all, let's go ahead and read this. It's supposed to say if the hypotenuse and one of the legs of a right triangle are congruent to the hypotenuse and corresponding leg of a second triangle, then the 2 triangles are congruent. I'm going to start by marking my right angle, and we always mark a right angle with a right angle symbol. Okay, so these are right triangles. That makes the side across from the right triangle the hypotenuse. And then that makes these the legs. Okay, so I'm going to start by marking the hypotenuse. If I can prove that the hypotenuse is congruent to hypotenuse, and then just choose one of the legs. I don't need both, just one of them. So legs congruent to leg. Then I know that those 2 triangles are congruent. The next one, okay, so if you look what we had so far, I've had side, 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 I've had 2 sides at an angle, and I've had hypotenuse leg, and then here I have 2 angles and 1 side. So here, this one should say, if 2 angles and the included side of one triangle are congruent to the corresponding that S looks like a G. So I'm going to fix that for you. Okay. The corresponding 2 angles and included side of a second triangle, then the 2 triangles are congruent. Okay, again, I just need to pick 2 out of the 3. So I am going to choose this one here, this angle, if I can prove that it's congruent to its corresponding angle. And then this one over here, congruent to its corresponding angle. Then all I need to do is prove that the included side. Remember, included means it's in between the 2 angles. So this side right here that's in between, that connects these 2 angles, that's the included side. And I'm going to go ahead and mark it. So we're talking about this one here and this one here. That's the included side. So if I can prove those 3 pieces of information congruent to those 3 parts, then I know that those 2 triangles are congruent. Okay, finally, I've had 2 angles and a side, so here's another combination of having 2 angles and a side. Double angle and then side. Okay, so this one reads, if 2 angles And so 2 angles, and see how side is on the outside? So that's not going to be on in between the two, so it's going to be a non-included and a non-included side of one triangle are congruent to the corresponding, I'm going to have to squeeze this in here, the corresponding two angles and non-included side of a second triangle, then the two triangles are congruent. Okay, so here, let's see what that looks like. I'm going to choose 2 of the 3 angles. I'm just going to choose the 2 base angles. So here's this one and this one. If I can prove that those are congruent, and if I can prove that these 2 are congruent, then I can't choose this side because that would be the included side. I have to pick one of these. I'm going to choose this side and this side. But you can choose the other side, it doesn't matter. Let's go ahead and mark this. This is the non-included side. So this one and this one around here. Okay, so that's it for our lesson. In part 2, we're going to go over some examples over notes 4.3, 4.4, and 4.5.